This lesson is to discuss the area and perimeter of triangles, trapezoids, and parallelograms. So let's get started. So a rectangle has a base and a height. They have a right angled corners, and opposite sides are equal. Sides are perpendicular. Area refers to the amount of coverage, so that would be the space inside of this shape. And the calculation is going to be base times height. B times H is how we abbreviate that. That's a formula. The perimeter is the distance around the outside edge, and so that would be as if you were an ant walking around this shape, and you could go side plus side plus side plus side, but the more efficient way of doing this is to calculate it as two bases and two heights. As a formula, that's 2 times b plus 2 times h. The base and the height are perpendicular to each other. In this case, they refer to the sides of a rectangle. Remember, base and height are perpendicular. And if we have a question dealing with a square, well, a square is the same thing. It's just a special type of rectangle. This shape is a parallelogram. Parallelograms are like rectangles that got kind of like knocked over a little bit, a little crooked. And so we need to regard a second or third measurement in this, and it's called the height. The height is going to be the distance between the parallel sides. We generally think of it as vertical, but it could be on a slant also, but it's got to be perpendicular to one of the sides, which that side we'll call the base. So the perimeter is the usual thing. You got 2a plus 2b, all right? 2a's and 2b's, you add up all four sides. Now to look at the area, we're going to split this thing up a little bit. I'm going to chop off that triangle at the end and move it over. And now it forms a rectangle. And this rectangle, we know how to find the area of it. We just did it in the previous slide. It's base times height. And so, again, same deal. There's got to be a right angle there between the base and the height, and that's going to be describing perpendicular dimensions for the area of a rectangle. And remember, this is still related back to the trapezoid. It's the parallelogram, so it's exactly the same formula. You don't have to redraw it to get it looking like a rectangle. Base times height gets you the area. They have to be perpendicular, okay? The base and the height. It is possible to have something perpendicular to A. We'll talk about that some other time. So here's a triangle. Now, to do a triangle, the perimeter is easy enough. It's just 3 sides this time. There's no special formula. It's just A plus B plus C. I put B on the bottom for base, and you're going to see why, because we're going to need something, we're going to need to use this as a base with a height. So I'm going to double this triangle. Let's see that again. I take the triangle, rotate it, and place it on the other side of it, so now we have a parallelogram. And like the previous slide, we know that we can calculate the area as base times height. Well, where's the height going to be? It's going to be perpendicular to the base. And there's got to be a 90-degree corner that shows that these two guys are perpendicular. Area is simply going to be base times height. But we were talking about a triangle, remember? So since this triangle is only half of the parallelogram, okay, so let's kill this part of it. It's going to be base times height divided by 2. Sometimes it's written a half times base times height, or b times h with a division symbol at the end by 2. Now a trapezoid is connected, believe it or not, to the same thing as the triangle or the parallelogram. Trapezoid perimeter, add up all 4 sides. There's no 2 sides equal, but a trapezoid does have a feature that the opposite sides are parallel to each other, and that's going to be important in recognizing where we're going to put the height in this shape. Line B and D are parallel, and so the height is measured perpendicular to both of those 2 sides, right? Because if it's perpendicular to one, it's going to have to be perpendicular to the other also. And now we can talk about the actual shape as being a pair of parallel sides. We're going to do base times height. We got 2 different bases, right? We got the base from here to here, which is B, right? That's the width, D. That's one of the bases. But then we could also regard the longer base of B, and if I found the area of that rectangle, that's going to be too big. So what do? Well, we're going to take the average of the B and the D. Okay, so we don't get the one that's too long, we don't get the one that's too short. We're going to average the B and the D, so you add them up and divide by 2. And then you're going to multiply that by the height. And that's going to give the area of the trapezoid. The key things to remember: the distance between those parallel lines is called the height. And so that's going to be base times height, but we're averaging the bases because we're not sure whether to take the B or the D. Hopefully this makes sense to you, and we'll continue with some problems practicing decimals and later on with fractions.